G'day again. Going to do a little video now on editing your G-code. That's G-code produced from your milling CAM software and how you can edit it to do spindle turning work. It's a bit complicated where you've got arcs involved, and I'm certainly not an expert on G-code programming, so I'm kind of struggling a bit through it, and I wanted to pass on what I've learned. There may be better videos out there. I can't find much information on it, so if you can find something, please send me the link. And in the meantime, you'll need to do a bit of study. The manual's a good way to go. There's a section on G-code in the G-code programming chapter on arc formatting, and if you understand that well enough, you'll be able to make the changes specifically to the requirements that you have. But I'll just go over it now for this particular situation. Okay, first of all, let's go through the CAD CAM. To start with, we want to end up with a turning setup in the mill spindle like this. We're going to turn it vertical shape here with the tool on this side. We're going to turn a chamfer, a diameter, generate a circular groove, and then a chamfer out or an angle out. But we're going to format it with our milling CAM software in this direction like this. Okay, so here is a view of the geometry. This is the diameter of the work. This is the end here on X0 level with the end, Y axis 0, the center line of the part, and that way the geometry is offset to give us the correct numbers. Obviously the X and Y numbers and Z numbers won't be correct, but the actual information, the values will be correct. And if we use multiple Toolpath cuts, for example offset profile cuts, we can have several cuts here. For the demonstration I'll just do one cut, but let's just run a simulation. Just to show you that this is what it would look like with the milling software. Okay. Okay, so I've done another page now with just one pass of the toolpath. Let's look at this closely. We've got a 1 millimeter radius groove that we want to cut, and our tool is a 1/16 or a 1.57 millimeter diameter tool, and so it's going to generate a series of arcs. The toolpath is forming 3 arcs, an entry arc, this arc, and an outward arc. Let's look closely at this because we need to understand the formatting and how it's defined in order to be able to convert it from an XY toolpath to an X or Y Z toolpath. So this is quite complicated, and you really need to read a little bit about it so you can fully understand this. When you've watched this video, I suggest you get the manual. Okay, where are we? This Toolmark manual is revision C14. So on that revision it's page 715, 714. Read that because it's quite involved, and you really need to understand radius arc format, center arc format, and so on. And then when you've read that, you might want to watch the video again. It takes a little while to digest. Your milling software, your CAM software, will, in conjunction with the post-processor, will produce code, and it'll be either to radius arc format or center arc format, and either in incremental IJ mode or absolute IJ mode. And you need to understand what type of format your software is producing in order to know how to modify it. In this case, it's CAD CAM version 25. It's center arc format and incremental IJ mode. And what that means is, bear with me because this is quite complicated. Incremental IJ mode, center arc format, it's all based off the start of the arc. So the toolpath's coming along here. The start of the arc is about here. At that point, it specifies. Now, can we see over here? We've got the code here on line in 12. We've got a G17, a G2, X and Y values, an I value and a J value on this first line here. Okay, let's go back to our drawing. So the toolpath's coming along here and it strikes line number 12, and we get a specification of G17. That's the XY plane. That needs to be changed to the Y or XZ plane, so we'll do that later on. G2, it's clockwise, or G3 anti-clockwise. Then you've got two coordinates, an X and a Y coordinate, and what that is specifying is the end point of the arc. And then the next two values are an I and a J, and what it is specifying is relative to the end point of the toolpath where this all started, and this is incremental IJ mode, so it's incremental relative to that point. There is an offset for the center point of the arc of, in this case, 0 in this direction and this amount in this direction, and that's the I and the J amount. Now you need to understand that well enough so that when you're doing the transferring of your code, you transfer the right values with the right code identification. Let me just reiterate that key point. Okay, here's our toolpath. We're starting here, we're coming along, and we're entering these three curves. Let's zoom in on that. When we begin the toolpath point of the arc toolpath, which is line number 12, we begin a set of code that needs changing, and we're at this point here, the beginning of the arc. Now, this milling software produces center arc format incremental IJ mode. That will be quite common. I would say most milling software will be like that. Let me just read from the manual. In the center format, the coordinates of the end point of the arc in the selected plane are specified along with the offsets of the center of the arc from the current location. So from this point here, the coordinates of the end point of the arc, it's a little green circle, are specified along with the offsets to the center line relative to that point. So the offsets in this direction, in this case, are 0, and we have an offset amount there. That is the IJ on the XY plane. Now when we change it over to, say, the XZ plane, there won't be I and J anymore. There'll be a K involved, and it'll be a little bit more involved, but we'll get to that when we do the transfer. But first of all, we need to understand this part of it. Okay, we're down in the workshop now. We've loaded the code into the controller, into PathPilot, and we're going to do the editing or the transferring from milling code to spindle turning code. And I wonder how many of you are still with me. How many have fallen by the wayside there'll be one or two hardcore people that really want to learn how to do this, but everyone else will be yawning and moving on to the next video. Okay, let's just run this quickly. Still in the milling mode, just showing it. Operating here. Let's go through it line by line so that we've got an understanding. Just setting up the tripod. Here we go. Right, we're just going to change over now to single block and just go through that code. You see the code on the other side and the screen. Maybe I can get a little bit closer. Alright, we're single blocking through it. Okay, that rapid move would not be good if we were turning, so we need to change that. Neither would that G30 retract and Z0 move. We need to change that. Now we're going to go to the first chamfer move, we want that. The next parallel move, we want that. Now let's zoom in on here. Here's the all-important arc moves. We're on line number 12, G17, and so on. It'll run this little arc now. And now we're on line number 13, line number 14, and straight move, and so on. Okay, now we're going to edit that code, transfer it round from XY milling code to Z or Z based turning code, spindle turning code. So let's open up the G code for edit. Now, there's going to be 3 stages of editing it that I think is a good way to do it for someone with my limited understanding anyway. First of all, I'm going to go through and remove all of the Z positioning or Z positioning, all of the clearance moves, rapid moves, the G30s and so on. That's easy enough to do. Then I'm going to go through and replace the X's with Z's, so that's the transfer of axes stage, and then finally the critical stage of changing around the arc formatting. So okay, starting at the top, I'm just going to go through and delete out, for example, G30. We don't need that. Return to tool change position. Let's go back, carry on down. We've got a tool change in there, we'll leave that for now. We've got a clearance plane there, of a Z value, we'll take that out. We don't really want any Z's in there because the Z's, if you're in America, the Z's are going to be a problem because we're going to be replacing them with a new set of Z's. So let's take that one out. So I'm leaving in the G1 and the F100 because that can also relate to the following line of XY moves. Carrying on down, don't see any more Z's. There's some here. Z 2.54 clearance plane and another G30 at the end of the program. Return to tool change position. We don't need all of that. Now I may have missed something here because I'm talking and my little brain is multitasking, but we'll assume I've got all of the Z's out of there. Now what we're going to do is replace the X's with Z's. So that's still recording, okay? Right, we're going to go search, replace X. Have I got cap on there? That's a bigger one. With Z. So we're just going to replace all. Click on that and it said found and replaced 10 occurrences. Okay. Now start again. We're going to now replace Y's with X's. Now why am I doing that? Well, you don't have to do this, but the way I've got the tool set over on the left hand side of the work, and I want to use the X plane because Y's with X's. I want to use the X plane because it gives me more length for different tool positions on the other side and so on. So okay, we're going to replace Y with X, so we're going to do it this way. Replace all 7 occurrences. Close. So okay, now we've changed our axes over, but be wary of the fact that you may also need to change from minuses to pluses, because I'm wanting to have the tool on the left hand side. I need to change all X minuses to X's, so I'm going to go back again, replace, and I'm going to put all X minuses replace with X's. Okay, so now we've just got hopefully everything correctly altered around there. Now let's save that for now and change the file on disk. Okay, we're getting some error messages there, but let's just see, okay, the error messages will relate to the fact that we haven't yet done the arc formatting, and you can see the arc formatting here is all haywire, as it would be because we haven't changed that yet, but we have got the basic profile now in the Z mode rather than the XY mode. Alright, so I'll take a breather now and study the next stage. Okay, now we come to the dreaded arc formatting. Remember we did that on the CAD CAM in the office, and now we're down in the workshop doing it on the controller. So what we do is we change on these 3 lines of arcs, we change the I's to K's. So I've just replaced those. I've taken out the I's and replaced them with K's, and replaced the J's here with I's. There's 3 of each. Now you also may find that if you load that and you get an error message, it may be that you haven't taken into account the fact that you've changed from positives to negatives or negatives to positives on one of the planes, and you need to apply that. In this case I needed to apply a negative to this one, take the negative out of this middle line and apply a negative to the 3rd line in order to get the equivalent in the XZ plane. Also change the G18 rather from G17 to G18, and again at the top from G17 to G18. That's plane select mode. G17 is XY, G18 is XZ. Okay, so let's save that now and see what we get. Okay, so now we're looking down on the top of the toolpath. Doesn't show much, so we need to do a front view, and there you can see the profile starting there, coming up. There's our radii and so on. So let's just run that, slow it down a little bit for safety's sake. Spindle's coming on. Okay, we need to change that retract, but coming down. Just run it over onto the machine so you can see it going. Okay, so now I'll just hand code in a retract move on the X and a Z retract of about 50 millimeters, and it's ready to go. Right back to the first take on the first video. I might put that in again actually, just so you can see the end result, or something very similar anyway to the end result that we've just got now. Okay, well let's start this video a little bit towards the end of the journey so you can get a feel for where it's headed. We're going to do some spindle turning, but not just normal Z X moves to turn face and diameter, but also we're going to turn radii or arcs and angles or chamfers. So here's a back plot of the NC code showing some angles and radii, and here's a little piece of sample acetyl to try it. Let's just run that now. Cutting a radius, cutting a straight portion, and cutting a tapered portion. So we have a radius groove, chamfers or angle portions, and plane diameters.